So this is another problem where we have future value of our income stream. Just again to review, this is if we have money coming in continuously throughout the year, our interest is compounded continuously, and our formula is set up to let us find the total amount after a few years. So K is the amount of money each year, N is the number of years, and R is our interest rate. So let's look at this problem, 6.5.25. An investment pays 10% compounded continuously. So R equals 0.1. If money is invested steadily at the rate of 14,000. Now, you have to go back and look at the textbooks, view an example because they typed this in incorrectly. We're going to kind of extrapolate a little because we know what section we're in, we know what they'd be asking. It should say at the annual rate of 14,000. So that means each year we put in 14,000. And they want to know how much time is required until the investment reaches 140,000. So that means they want the future value to be 140,000. And we are supposed to figure out what N is. Okay, so this problem is different. So we still set up our integral. But now, future value, we know what that is. So we have sorry about that. Maybe grab the keyboard. So we want to have 140,000 equal to the integral from 0 to n of k, which we know is 14,000, times e to the 0.1 times n, because we don't know what n is, so we're going to leave a blank, n minus t dt. Now, again at this point, I'm going to rewrite this. So it's still 0 to n, 14,000. I'm going to say this is e to the 0.1 n minus 0.1 t dt. And anytime you have an addition or subtraction in your integral, or in your exponential, you can rewrite it as a multiplication. So this is e to the 0.1 n times e to the negative 0.1 t dt. Now, even though this n looks like a variable, it's not, because we don't know what it is, but it's still treated like a constant. Okay, not a variable, but a constant. Unknown, but a constant. And so that means this entire thing is a constant, and we don't have to worry about it. So let's go ahead and take our integral. Our whole 14,000 e to the 0.1 n stays there. And then we have e to the negative 0.1 t divided by negative 0.1. So you always divide by what's in front of that t when you evaluate the e, or integrate the e, from t equals 0 to n. So we just put an n in, just like we would any other number where we see the t. So this is going to be 14,000 e to the 0.1. Now there's already an n there. That's okay. E to the negative 0.1 n over negative 0.1. So we'll do that minus, now we do the 0. So 14,000 e to the 0.1 n e to the negative 0.1 times 0 over negative 0.1. Okay. Let's see what we get here. Now this e to the 0.1 n and e to the negative 0.1 n, if we add those together, they're actually going to cancel. Or if you think about it, it's e to the 0.1 n and times e to the negative 0.1 n. That negative means put it on the bottom, so you'd have e to the 0.1 n over e to the negative 0.1 n. And any way you want to think about your algebra, those two things cancel. So we're just left with 14,000 over negative 0.1 minus, or let's make it a plus, 14,000 over 0.1 e to the 0.1 n, and this e to the power of 0 is just going to be 1. Let's simplify that just a little bit more. So we have, let's see, what is 14,000 divided by 0.1? So we have negative 140,000 plus 140,000 e to the 0.1 n. So this is what our integral is. And if you scroll back up, remember we wanted it to be equal to 140,000. So let's now make a new problem. Okay. Let's set 140,000, that's what I wanted my entire integral to come to, equal to what I got from my integral, which is 140,000 plus 140,000 e to the 0.1 n, and solve for n. So we add 140,000 on both sides, so we have 280,000 equals 140,000 e to the 0.1 n. We can divide both sides by 140,000, so we get 2 equals e to the 0.1 n. At this point, to get rid of this e, you take the natural log of both sides. So natural log of 2 equals 0.1 n. And divide both sides by 0.1, so you get 10 times the natural log of 2 equals n. Now this is about 6.931. So it will take about 6.93 years if you put in $14,000 a year for your interest or your total amount to get to 140,000.